The next pitch from Detection Services, Chris Evans. Chris, can I ask you to get into and then come out of your virtual limousine and come up to the stage?
Hi. Can you see me okay?
Oh, yep, there we go. Hi, Chris. Are you sitting comfortably?
I think so.
Excellent. All right. Thanks, Chris. Take it away, please.
Thank you. All right, so good afternoon, everybody. My name is Chris Evans. I'm the General Manager for Detection Services. And today, the intent is to alert the market about new technologies that can improve the speed and confidence in detection of potable leaks in water supply zones and DNAs. Next slide, please. So we probably need to click through that, I guess, but essentially, Detection Services delivers the majority of all non-revenue water programs in Australasia. We've deployed over 40,000 leak noise loggers in 10 environments. We've deployed acoustic and pressure sensor networks in every capital city in Australia and New Zealand, and we appreciate the difficulties faced by clients in reducing losses, particularly at the moment in these challenging times, I guess. So the problem that we see and has manifested itself is deciding if an acoustic logger or leak logger has picked up leak noise, or is picking up the noise from a nearby air conditioning unit. A bit of a challenge, really, for clients in field detections. Next slide, please. So the solution, and we've heard about this again this afternoon, is to use artificial intelligence, AI. And so FIDO Technology is a company that leverages the power of AI with an algorithm which is able to detect leaks accurately, safely, and efficiently. As I said before, the current problem faced by utilities and non-revenue service providers is that acoustic data can be quite subjective in terms of confirmations of leaks from acoustic loggers. Time spent in confirming the anomaly can be lengthy and further made difficult by factors on site traffic and other external noise influences. The solution to this can be delivered in two phases. Existing acoustic loggers are able to upload sound files into FIDO AI for an immediate comparison with an increased confidence rating, allowing the client to target largest leaks without human intervention. Using the hardware, FIDO Lite, the technician can be dispatched very quickly to identify a location, generally within 1 meter of the confirmed leak. Next slide, please, if you can. So it's a two-stage process. An existing acoustic fleet delivers sound files to the AI platform. The platform itself is agnostic in terms of hardware. It takes anybody's sound files and uses the rapidly growing FIDO library, which compares instantly the noise file to over 1.4 million sound files. FIDO is confidently able to predict leak locations with an accuracy of over 90%. Stage two is using the FIDO Lite hardware. This is where it becomes quite interesting. So technicians are able to quickly locate leaks with a really high degree of accuracy and confidence. The beauty really has been how quickly this can be achieved over normal traditional methods. So just in summary here, FIDO AI will confirm and prioritize leak locations and direct technicians to sites generally within 100 meters of the leak. And using FIDO Lite, which is again on the screen there, you can see the technology, will allow pinpointing within 1 meter and allow faster coverage of the network of a traditional method such as stop tap survey, for example. Next slide, please. Okay, so again, this technology is moving on very, very quickly here, and the beauty of this sort of approach is quite novel. So there are 4 uses for one logger, or a PUC, as it's called. There's 4 applications. In listening stick mode, it converts the traditional listening stick method using the PUC with information able to be collected down to 0.5 of a hertz, which is obviously, as you know, is very low. We're going to load that directly into FIDO AI. The technician gets immediate confirmation through his web app, confirming the location with a degree of the confidence rating. It really is quite quick and really is quite accurate. In logger mode, it acts as a standard acoustic logger, and particularly effective in zones that an established acoustic logger fleet speeds up the lift and shift process. And then moving on into mode, the PUC forms the brain for the HD camera, which can be inserted into a live water main, listing and pinpointing leaks. And then more excitingly, the ability to launch the PUCs in free flow mode. You install them into the water main, they'll flow down the main up to 7 kilometers, picking up leak noise and location data, and then use the AI platform to confirm leak locations. Next slide, please. So currently, FIDO is making significant ground. It's just signed a 5-year agreement with the United Utilities in the UK to work with them to develop the FIDO AI platform and also to deliver some hardware and on-the-ground support. Significant project. Also, they've got some trials and phase deployments with 4 major UK utility companies. I think we made the point earlier on. The UK is a very difficult and a very focused regulatory environment, so the ability to find and locate leaks quickly is obviously a bit of a bonus. FIDO and FIDO Lite has been rolled out across Johannesburg in South Africa, and FIDO and Detection Services are working on a pilot project with a leading Queensland utility. It's also a finalist at TAG Europe 2020 and has filed 3 patents for the technology. Next slide, please. So the challenge is this: we want to challenge this hardware, we want to challenge the ability of the platform to really help speed up the process of leak detection. So we'd like to work with a client to deploy FIDO Lite loggers in a selected DMA to show you firsthand how quickly and easy the 2-step process is. We want to be able to demonstrate this process, which is, we suggest it's groundbreaking, which will reduce leakage across your network, build water resilience, and also reduce the amount of exploratory investigations, dry holes, and wasted time. Challenge being to demonstrate how effective the process is against your normal methods of leak detection. Thank you very much.
That's great. Thank you very much, Chris.